7.1, is it a function or relations notes? So this is kind of one of the beginnings of more complex thinking about how math is more thinking piece of it. And so there are relations and functions. So relations pairs inputs with outputs. Functions are, the definition is very specific. It says each input has exactly one output. And that's very important. Now, to me, this gets really confusing. So, to start off with, think about this. This is sort of like rectangles and squares. So, if I write down this figure, what would you name it? Well, we would say it's a square. And so, but is it a rectangle? Yes, it is. But do you call it a rectangle? No, we usually don't call it a rectangle. We call it a square. So that square kind of idea is the same as function. Yes, a function is a relations, but we don't normally call this figure over here a rectangle. Even though the definition, it is true for the definition, it is more specific that it's a square. So that's what the function is in algebra. So we want to kind of remember that each input has exactly one output, and that we want to kind of keep in our head. Now, I'm not as good with this wording piece of it. So what I like to do is go with the what we call the vertical line test. The vertical line test. And what that is a graph. So we want to I'm going to label this graphs. And we're going to look at the graphs and see, is it a function? And that's what we're going to ask ourselves for this problem. Is it a function? So we'll just do a quick little sketch of a graph. So we'll put a point here, a point a little bit lower, something down here, and then we'll put one here, here, and here. So make sure these two kind of go there and there. So we got a bunch of points. So now what I'm going to do is take my I usually, when I draw this on my paper, I take my pencil and draw and kind of come across. So I'm going to draw this up and down and see this pencil coming across, and I hit this point, and I'm going to ask myself, does this input have one output? And yes, it does. It has that one output. So I like to sometimes, I'll put a dashed line on here thinking this is my pencil drawing across the paper. Now remember, we always start from the lowest numbers down here at our number line, the lowest numbers we can go, and go up the number line. So my pencil now, so right now I can think of it as, yes, it is possibly a function because there is that input had exactly one output. So now I'm going to go over here and kind of look over to my next point and go, hey, this point right here, when this input had exactly one output. So it's looking good so far. I'm going to go to the continue on down or up the number line and get this one down here. This input had exactly one output. Now I'm going to continue on and go, oh, at this input, I have another input. So this input, yep, had one output. So this input had exactly one output. And I get to this one right here, and this one had one output, not just one output, but two outputs. So right here, it has the input had two outputs. So that means it's not a function anymore because it needed to only have exactly one output. So that means this is a relations because of this spot right here where these 2 points, that input had 2 outputs. So now let's take a look at the second graph. What would one that had all outputs that are inputs that have exactly 1 output? So we're going to kind of make our graph sort of similar, but when we get to this spot over here, we're going to go 1 output, and let's make it horizontally the same, okay? Because we made these the vertically the same. Here we're going to make them horizontally the same. So I'm going to take my vertical line test, my pencil, starting over here on my paper and drawing it across, going up the number line. So I'm going to start here, and I hit a input that has exactly 1 output. So I'm starting good. Go to the next input right here and has 1 output. This input, the next one has 1 output. The next one, continue it on. Here's my next input, has 1 output. And then now I get to these doubles, what I like to call the repeaters. And this input, even though the output is the same, this input has exactly 1 output. So it does have exactly 1 output. Now I'm going to go to the next one, and this one has exactly 1 output. So this is a function, and it's a function because it passed the vertical line test. And in mathematics, that is very important. So that reasoning, you can use that reasoning of vertical line test, pass the vertical line test, or over here you could say it didn't pass the vertical line test. And it's up there with, say, the distributive property. You know how important that distributive property to mathematics is. And that vertical line test, it doesn't sound like it, but it is that important to determine if it is a function or not. So now there's going to be different ways that we decide, or different ways that it's presented, and we're always going to ask ourselves, does each input have exactly 1 output? So we're going to do coordinate pairs. And those coordinate pairs, let's start with our first example, 1, -1, 2, -3, 1, -2, and 1, -4. So, and first looking at this, for me, it's a little bit harder, even knowing as a math teacher that each input has exactly 1 output. So I have a really more difficult time doing that, which I know it shouldn't be at this time. I should be able to do that really easily. But for me, the wording kind of gets in my way. Some people are really good at the wording and they kind of see it and understand it. But for me, what I do is I go to that vertical line test. And I know, and I don't know if you noticed back when we were back up here, see these, what I call singletons, this one by itself, this one, and this one, and this one. These 4 on each one that were singletons, they were always a function. So I'm going to look on here and find those kind of ones that are singletons. See how this 2, -3 doesn't match up with any of those other ones? This 1 as an X, and 1 as an X, those are what I call the repeaters. That's my made up word, Mr. Haydn's word. But it helps me kind of look for those repeaters, because those are the ones that are this one up here that are horizontal, or they're vertical. And so what I find is that I can, in a coordinate pair, I have a hard time visualizing that. But once I put it on a coordinate pair, I kind of go bing. So they all have a 1, and this one is a -1 down here. That's that first pair. The second pair is 1, -2 down here. And that right there, I don't even have to do the third one, tells me that it is not a function. So it's not a function because it didn't pass the vertical line test. Or the input of 1 had more than one output. It didn't have exactly one output. So not a function. And for me, I would say it didn't pass the vertical line test. So number 4 for the coordinate pairs. Let's do 2, 4, 3, 5, -2, 5, and -3, 3. So now for this one, I'm going to look for those, and I'm going to do that vertical line test. I'm going to look for those repeaters. So I'm looking for in my inputs, oh, they're all different, 2, 3, -2, -3. And my Y, my outputs are 4, 5. Oh, there's the repeater. 5 and 5 as my outputs. So I'm going to just graph those two because these two other ones are going to be like these over here on the left up at the top all by themselves. So I know that. So my repeaters, I just have to do those. So 3, 5, and let's go right up there about 5. So now -2 over this way, up 5. So that tells me right there that this is a function because every input has exactly one output. So function. I love writing function. All right, so now the next format that we might be given is mapping diagrams. So remember, a mapping diagram just pairs the inputs and outputs. But it does it in a special way, and it maps them with arrows. So we're going to start off with our inputs. So let's do this first one, these coordinate pairs. So I notice my inputs are a 1, 2, 1, 1. So remember, no, we don't like rewrite them. We just write a 1 in the group and a 2 in the group. Now the outputs were -1, -3, -2, and -4. So I'll start with my -1, -2, -3, and -4. I like to do mine in a nice organized way, order. Now I'm going to map them with arrows. So my 1 goes to -1, and I'll draw an arrow there. 2 maps to -3. 1 maps to -2. And 1 maps to -4. Now, we do have to determine, so sometimes we're given this mapping diagram and asked, is it a function? And I'd be like, I don't know. Well, we can do the same thing that we did up here with the coordinate pairs. We can just make a coordinate pair. So we want to look for the 1 repeaters, which are the 1s. I can see the repeating much easier here than I was able up in the coordinate pairs. So 1 maps to -1. So 1, -1 right there. And 1 maps to -2. And remember, we already did that up here, but looking at it here, we can do that same thing and say, hey, not a function. Well, what would we call it if it's not a function? Well, we would just call it a relations. That was that other word. So, but a lot of times they're asking, is it a function or not a function? And that's what we would have to kind of click. Is it function? Is it not a function? And that's how we do our mapping diagrams. Now, when we're given we might be given a table and having to do that same thing. So we're given different formats, but we're being asked that same question. Is it a function? So 0, 1, 2, 3 for our x's, and they pair up with -4, -2, -4, and -6. So now we're going to look for those repeaters. So the repeaters, and as I was writing them down, I was like, oh, there's one and there's one. They both have a -4 for the y value. So there, is it a function or not a function? So here's where I think. This is my thinking graph, and I should have done that up there. I don't even put arrows on it. I just do a quick graph because I want to see, are they stacked on top of each other? So 0, -4 is down here, and 2 over here, -4. So that tells me it is a function because the passes the vertical line test. Function. So yes, it is a function. And if they ask you the reason why, because it passes the vertical line test. Done. And that's the reason why it is a function. All right, so that was, oh, I forgot to number it. That was number, let's see, 4. This would have been 5. This would have been 6. And then we'll do 7, table number 7. So x, y, we'll do 4, 6, 3, 5, 3, 7, 2, 7, and 10, 12. Now, is it a function? So I noticed that there were 2 sets of repeaters. So my guess is if given this, the reasoning would be they would want a little more with the reasoning. So what I'm going to look for are these 2 repeaters and these 2 repeaters. And I'm going to ask myself which one of those makes it a function or not a function. So I'm going to do my vertical line test because I love my vertical line test. It just makes a picture for me and it just helps me have a good reason of what yes it is or no it is not a function. So I'm going to graph the 3's first. So 3, 5 over 3 and up 5 over 3 and up 7. Aha! There it is right there. So these 2, it's because the 3's have 2, or the 3 has 2 outputs. So not a function because the input of 3 has 2, let me use the word 2 here, 2, that would fit better, 2 outputs. And I'm going to name them 5, 7. And that just helps make that reasoning so much better for why it is or is not a function. Now, let's do one last one. And this is a graph. Which number was that? Now it's 7, so this one is 8. So if given a graph, and here is my graph, so it's a little different than before. Is it a function or not? So again, I'm going to use my vertical line test, and I'm going to test. Now, a solid line, remember, is a bunch of points. Now, how many points are there? Well, it's an infinite number of points. So you can get smaller and smaller all the way down. Instead of putting all those points there, we just connect them all together and make one solid line. So what I'm going to do is think about that input for every single one all the way down into the really small pieces. So is there one output for every single input? And there is. That means that every input, every infinite input, even though it's not on the graph, it may be way down here, has exactly that input, has exactly one output. So this is a function. And that is how we determine if it's a function or not a function. And here I used the vertical line test to help us determine that.